Hello everyone, myself Dr. D. Sree Lakshmi, Assistant Professor in the Department of AIML at Institute of Aeronautical Engineering. In this session, I am going to discuss about Ramanujan's method, which is used to find out the roots of the given polynomial. So here, Ramanujan's method is also known as iteration method, which is used to find out the smallest root of the equation. And the given equation is f of x is equal to 0. And here, the first step is, whichever equation is given or whichever function is given, we need to convert that equation in the form of 1 minus of a1x plus a2x square plus a3x cube and so on. So, as per this equation, or we can name it as per equation 1, we need to convert the given function. That is our step 1. And now, the step 2, to find the smallest value of x, we need to compare this converted function with b1 plus b2x plus b3x square and so on. So, which one we are comparing? The converted expression is equating with b1 plus b2x plus b3x square plus so on. Here, if you observe carefully, f of x we are taken and then we are making it as f of x 1 upon f of x, and then this f1 by f of x, that is 1 upon f of x, is compared with b1 plus b2x plus b3x square and so on. From this comparison, we will get an equation like 1 plus a1x plus a2x square, and this is power 1 terms, and similarly power 2 terms, and similarly power 3 terms. All these terms will be equal to b1 plus b2x plus b3x square and so on. By equating the power of the two expressions, we will get the values. b1 is equal to 1, b2 is equal to a1 b1, b3 is equal to a1 b2 plus a2 b1, or else you can write it as b3 is equal to a2 b1 plus a1 b2. The terms can be interchanged. And here, the final expression given to find out the b values as b suffix k is equal to, where k is equal to greater than or equal to 2. K should be greater than or equal to 2. And the formula is ak minus 1. That is, if I take b6, then this is a6 minus 1 b1 plus a6 minus 2 b2 plus and so on plus a1 b6 minus 1. So, what it indicates? a5 b1 plus a4 b2 plus a3 b3 plus a2, this is b4 plus a1 b5. So, like this, we will generate the power of the both equations, both LHS side and RHS side, and then we will get these all values. After that, finding out these values, we will there to find out the root of the given polynomial expansion. So here, to find out the roots, the formula is bn by bn upon bn plus 1. So that means b1 by b2, b2 by b3, b3 by b4 and so on. This gives the root value, or we can say this is called the convergent approach in the limit the smallest root of f of x is equal to 0. We will say that to find out the smallest root, Ramanujan's method is used. So here is an example to find the smallest root of the given equation x cube minus 9x square plus 26x minus 24 is equal to 0. For this, we need to find out the smallest root. So initially what we need to do is, we need to convert this into 1 minus of a1x plus a2x square plus a3x cube and so on. This format need to be maintained. So the given function is x cube minus 9x square plus 26x minus 24 is equal to 0. So how to convert this into this particular format means, divide entire equation with minus 24. So here minus 24 by minus 24 plus x cube by minus 24 minus 9x square by minus 24 plus 26x by minus 24, or else you can change this in a one particular format. So here 1 minus x cube by 24 plus 9 by 24 x square minus 26 by 24 x. So since the terms given in the equation as 1 minus of a1x plus a2x square plus a3x cube, I will convert this in that form, right? So 1 minus of, I will cancel this. So 12 by 13 x, and next x square term. This will be minus, and here it is 1 by 3 by 8. So 3 by 8 minus 3 by 8 x square, and here it is 1 by 24 x cube. So we converted the given function in terms of minus 1 minus of a1x plus a2x square plus a3x cube. From this equation 1, we will fetch the quotients. a1 is equal to 12 by 13 and a2 is equal to minus 3 by 8 and a3 is equal to 1 by 24. After getting these values, a1 is equal to 13 by 12, a2 is equals to minus 3 by 8, a3 is equal to 1 by 24, and the remaining terms in the equation, they are zeros. a4, a5, a6 are zeros. Now, equating this with b1 plus b2x plus b3x cube, b1 plus b2x plus b3x square plus so on, we will get these formulas. Substituting the values a1, a2, a3, a4, a5, a6 in the above equation, you will get b1 as 1. Since the equation C, 1 minus of 13 by 12 x minus 3 by 8 x square plus 1 by 24 x cube. So here a1 is 13 by 12, a2 is minus 3 by 8 and a3 is 1 by 24. Now see here b2, a1, b1, where b1 is 1, a1 is 13 by 12. So b1 is 1, b2 is 13 by 12, which is taken in decimal representation. Now b3, a1, b2 plus a2, b1, the values which we are having, b2 is having here and a1, a2, a3 are listed here. By substituting in this formula, you will get minus 0.786. Like that, we will continue to find out up to b8. Since 1.8862, again for b7, the value is repeated 1.8862. So here we stop at this one and then we calculated b1 by b2. So here B1 by B2 need to calculate. That is 1 by 13 by 12. So like that, B2 by B3 we need to calculate. That is 13 by 12 by, what is B3 here? 0.7986. 0.7986. So here will be the values. Similarly, B3 by B4, 0.7986 divided by 0.5007. Next, B4 by B5, so 0.5007 divided by 0.2880. So like this, with all the values of B1, B2, B3, the convergence values will be found out. Whenever it approaches, or the iterations if have the same values, then we will stop the iterations. So here iterations means B1, B2, B3 and so on, and the root value is B1 by B2 calculating, B2 by B3 and B3 by B4. So now we will assume that the values, so the first value is 0.9230. I am going to take up to only 3 decimals. Next, 13 divided by 12 upon 0.7986. So this is 1.356. And next, B3 by B4, 0.7986 upon 0.5007. And this value is 1.594. Next, B4 by B5, 0.5007 upon 0.2880. 1.738. And now I am having some more values, B5 by B6 and then B6 by B7, B7 by B8. So B5 is 0.2880 divided by B6 value is 0.1575. 0.1575. How much this value? 0.2880 divided by 0.1575. So this is 1.828. Next value, B7, 1.8862. 1.8862. So 0.1575 upon 1.8862. 0.1575 upon 1.8862. So here the value is B7 1.8862 and again this is 1.8862. So here this is approaching to the same value and we can conclude that the smallest root of the given polynomial is 2 or 1.828. This is continuously moving on. So we can conclude that the smallest root of the given polynomial equation is 2. Like this, we will use the Ramanujan methods for the polynomial to get the root values. Here is an example where we can apply the Ramanujan's method to find the smallest root. Only the conversion we need to consider here. When f of x is given, this we need to change. Here cos x is given. So here we need to implement the cos x expansion. Since it is even function, we will take x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on minus 1. This equation need to be converted into 1 minus a1x plus a2x square plus a3x cube and so on. So this is left for the students, you can use the same formulas as B1, 1, B2, A1, B3, A2, B1 plus A1, B2. So these formulas you can use and you can find out the root value. And the content is taken from SS Sastry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.